Hello all, let's start section 1.4. Your section 1.4 is complex numbers. The first thing that I want to discuss here with you in this section with the complex numbers, let's review a little bit. If I have someone ask me, what is the square root of 4? Immediately you can answer the square root of 4 is positive negative 2. The reason that we learned is that if you multiply positive 2 with positive 2, which means you square it, right? Positive 2 is square, it gives you 4. Or if you multiply negative 2 with negative 2, it means if you square negative 2, it gives you again positive 4. Correct? It means the square root of a number is a number that if it multiplies by itself once, it should gives you the radicand. The radicand means the number under the square root, correct? Now, if I ask you what is the square root of 25, easily plus minus 5. But if I ask you what is the square root of negative 4, what will be our answer here? What is the square root of negative 4? Because if I multiply 2 with 2, positive 2 with 2, it gives me positive 4. If I multiply negative 2 and negative 2, again, it gives me positive 4. And I cannot do this to multiply negative 2 with positive 2. I say, oh, 4. This is wrong. It's not the square root. You cannot multiply two different numbers. A number should be multiplied by itself. And in both cases, you see your answer is positive. Then what is the square root of negative 4? In the past, even before you jump to intermediate algebra, for these kind of problems, when you're facing a negative number under the square root, your answer was no solution. They don't have negative numbers, doesn't have a square root. This is what the teachers told you at the school level and at lower level, that the negative numbers doesn't have a square root. Now, when you come to intermediate algebra, when you come to college algebra, there is a solution. There is a way to represent the square root of negative numbers. What we do here, instead of writing square root of negative 4, or if I ask you, what is the square root of negative 1? Let's first answer this one. What is the square root of negative 1? They named here the square root of negative 1, I. I represents the square root of negative number. Now, what is I? They called I imaginary number. Imaginary number. Imaginary means this number is not on the number line. You cannot find I on the number line, correct? There is no I on the number line, but can at least take the square root of negative numbers. What they're using the symbol of I, which means imaginary number. Now, the square root of negative 1 becomes what? I. If you square both sides of this equation, this side and this side, let's just square it and see what's happening. If I square this side, square root of negative 1 square, I have to square this side too, I square. Here, square with the square root cancels out. Then I can write I squared as what? -1. Remember these two. These two is the basis of dealing with complex numbers or imaginary numbers. The square root of -1, we name it I, and I squared always gives you -1. Now, simple problems, how to find the square root. I will show you in more detail, but later you don't need to write all these steps. Just immediately answer what is the square root. For example, what is the square root of 25? How to find the square root of 25? I will rewrite -25 as a square root of -1 times 25. Can I do this? Definitely yes, -1 times 25 gives me -25. I will rewrite based on the rule of radicals. If you remember, I'll put first the rule here because you will ask me why you did this. If you have a square root of a times b under one square root, you can rewrite this as a square root of a times a square root of b as a two separate radicals. If I use this method, if I use this law, then here I can write the square root of -25 equals square root of -1 times the square root of 25. What is the square root of -1? I already found we named the square root of -1 I. What is the square root of 25? The square root of 25 is 5. Then my answer is 5i. Here I show you all the process, right? Why the square root of -25 is 5i. But in other problems that you see somewhere like this, a square root of -64, you don't need to follow all those steps. What is the square root of 64? 8. What is, and because it's negative, you just put an I. Then the square root of -64 becomes what? I. Correct? This is all about imaginary numbers. After you learn what is imaginary number, let's discuss now complex numbers. What is a complex number? A complex number is a number that's in the form of a plus bi. I will explain to you what is a, what is b, and what is bi. A complex number is a number that's in the form of a plus bi. In this form, a and b are real numbers. And I is your imaginary number, correct? Imaginary part or number. For example, 2 plus 4i. We call this one a complex number, correct? Next example, 3 minus 2i. It's a complex number. 0 plus 5i. It's a complex number. In the example that I have 2 plus 4i, we call 2 the real part or real number. Usually they call it part. 2 is your real part. 4i will be your imaginary part, correct? Imaginary part. In this example, which you have 3 minus 2i, 3 is your real part, 2i is your imaginary part. In the example that I have 0 plus 5i, 0 is your real part, 5i is your imaginary part. Now, a question rise up after the last example, 0 plus 5i. We learned something. If I write 2i, can I say 2i is also a complex number? Should I say yes or no? Or I just say, no, 2i is just an imaginary number. Can I call this one also a complex number? Definitely yes. Remember, any imaginary number that doesn't have a real part, immediately you can write it as 0 plus that number. For example, in this example, 0 plus 2i. Then any imaginary number also represents a complex number, correct? Remember, your standard form is a plus bi, real part and imaginary part, correct? You cannot, oh, some people want to write this way, bi plus a, and say, oh, there is no problem with, yes, there is no problem with, it's the addition rule. But usually this is our standard form. We want to write our answer always in the form of a plus or a minus, it doesn't matter, a plus bi or a minus bi, correct? And we call it, these numbers, imaginary, complex numbers, correct? One of the very important rules of complex number is equality of complex numbers. What we have in this rule, if I have a complex number a plus bi, it can be equal to another complex number c plus di, only and only if a is equal c and b is equal what? D. Two imaginary or two complex numbers can be equal to each other only and only if their real parts are equal to each other and if their imaginary part is equal to each other. In that case, you can say these complex numbers are equal to each other. Later, maybe we solve some imaginary equations, correct? Even you can solve some equations using this property. It's really interesting problems. You can find the value of A and B, or the value of your variable when you have a complex number equation, correct? I don't know, I think they don't want to use this part in your book, but in other editions of college algebras, we even solve these problems, correct? Using this property, important property of complex numbers. Now, after I introduce to you, now we start slowly the operations, which is really easy lecture. Operations with complex number. Complex numbers. It means you can add complex numbers, you can subtract complex numbers, you can multiply complex numbers, you can divide complex numbers. The the four main operations that we have in mathematics, you can apply it also on complex numbers. To give you a little bit extras, since mathematicians found complex numbers, there was a huge, big move in the world of mathematics. It helped a lot the development that we have today after they found and they used complex numbers. It doesn't mean why I'm dealing with imaginary number, it doesn't exist, but later when you come to higher level classes of mathematics or you go to engineering field uh, in a high level, or when you go to economy or business in a high level, you will see that these imaginary numbers or complex numbers, they have a good use and help you a lot to find other formulas, correct? But let's start right now with the operations. First, addition. Let's add complex numbers, or let's learn how to add two complex numbers. I'll write here an easy rule. I have to show you the rule as it is in your book, but when we deal with the problems, there is another easy way that you deal with the addition or subtraction of complex numbers. What is the rule? What the rule says? If I have a number, a complex number of a plus bi, and I want to add it with another complex number of c plus di, what should I do? In this rule, it says to you, add the real part with the real part. It means add a with c, and also add the imaginary part, which is b and d, correct? Add these two, b plus d, and keep your I at the end because it's an imaginary part. I'll do an example under that, and then I'll put the subtraction rule, correct? For example, I want to add 2 plus 3i with 5 plus 7i. What I do, I'll add the real part with the real part. 2 plus 5 plus, and I add the imaginary part with imaginary part. 3 plus 7, and I'll keep my I here. Now simplify. 2 plus 5 gives you 7, plus 3 plus 7 gives you 10i. This is the kind of professional way, or the way that rule says to you, you can follow and you can answer your problem, and you can add any 2 or 3 or 4 or 5 complex number together. But the easy way, if I show this example, or let's do another one, 4 plus 9i plus 8 plus 2i. I don't want to show all the steps. As soon as I learn the rule, I know I will add 4 with 8, which gives me 12. Plus, I will add 9 with 2, which gives me 11, and I put I. My answer is 12 plus 11i. I told you this section is really easy, correct? Same way, we have subtraction rule. If I have a number a plus bi, and I want to subtract from a number c plus di, another complex number, basically the rule is the same like addition. What I do, I will subtract A minus C, the real part from the real part, and I will subtract B from D, and I'll keep my I at the end. Numeric example. 4 plus 2I minus 3 plus, let's say, 8I. What I do here, if I apply the rule, I will write 4 minus 3 plus 2 minus 8, and I'll keep I. 4 minus 3 gives me 1, plus 2 minus 8 gives me negative 6I. And if you simplify, it means 1 minus 6I. But again, easier way, which I like, which I always use that method. I don't want to follow these rules, make a problem long for me. There is another easy way. 3 plus 6I minus, let's say, 4 plus 9I. What I do, I'll keep my first parentheses. I'm thinking like this way, that I'm dealing with this two parentheses. 3 plus 6x minus 4 plus 9x. How you deal with when you're adding to algebraic expression? First, you distribute the negative, right? I do the same thing here. I'll write 3 plus 6I minus 4 minus 9I. Now I'll combine like terms. That's the way that I deal with. This is the easiest way. 3 minus 4 gives you negative 1. 6I minus 9I gives you 3I. Final answer. Easy way. Correct? Easy way. Just think, when you add, when you subtract complex numbers, just think that you are dealing, or you are adding and subtracting algebraic expressions. The method is totally the same. Correct? Let's do another example. For example, negative 5 minus 11I plus 7 plus 4I. Let's put even here negative. In your book, it's positive. I want to use here also a negative. Okay, keep your first parentheses. Negative 5 minus 11I. Distribute the negative here. Minus 7 minus 4I. Now combine like terms. Negative 5, negative 7 gives you negative 12. Negative 11I, negative 4I gives you negative 15I. Final answer. Very easy. Correct? The next one is multiplying and dividing complex number. I don't want to put everything in one lecture for you. What I do, I'll name the second part as a complex number, and I'll stop my lecture here and see you next time for the part 2 of this lecture.